Bacterial cellulose with gold shifts color under pressure.
Welcome to The Explainer. Today we're talking about something that sounds like it's straight out of science fiction, but I promise you it is very, very real. We're looking at a film, a material that can actually feel pressure and then show you what it's feeling, just by changing its color. I mean, just think about this for a second. What if a bandage could tell you how a wound is healing? No electronics, no wires, nothing. Just a simple dressing that changes color to signal something like an infection. This isn't a fantasy. This is the future, and it's being built right now with these incredible new smart materials.
And really, it all starts with this. A totally revolutionary material that can sense physical pressure. And its response? It changes color. You could almost say it's a film that hears touch. Okay, so what exactly is this stuff, right? In this first part, we're going to dive into the basic breakthrough here. We're talking about a material that gives you a direct, visible response to force. You press it, and it literally shows you that it's been pressed. Simple as that.
You know, if you saw it in the lab, you might not think much of it. It just looks like this reddish, kind of gel-like disc. But when you press on it, something really remarkable happens. The color, it just darkens and shifts. And what's wild is, the harder you press, the more it changes. It's a direct, measurable, and totally repeatable effect.
And of course, this brilliant phenomenon has a pretty cool name, the Mechanoplasmonic effect. Yeah, I know, it's a mouthful. But it's really just a fancy way of saying that a mechanical action, like pressing on it, is directly changing how that material interacts with light. It's a physical link between force and the color our eyes see. Super cool.
Okay, but how does it actually work? The science might sound super complex, but the idea behind it is actually something we can all get our heads around. Let's use a simple analogy. Just picture a sponge, okay? But this sponge is filled with millions and millions of tiny, colorful beads.
So first up, we have our sponge. This is something called bacterial cellulose. It's a totally natural material that basically forms this microscopic 3D web of fibers. It's super porous, and maybe most importantly, it's biocompatible. That just means it's safe to use with living things, like us.
All right, now for the beads. These are actually gold nanoparticles. We're talking impossibly small little bits of gold that are just suspended inside that cellulose sponge. And it's these tiny gold particles that give the material its unique red color when light bounces off of them.
Okay, so here's where the magic happens. It's all about how these two parts work together. When the material is just sitting there at rest, those gold beads are all spread out, and so the film looks red. But when you press down, you're squeezing that cellulose sponge, right? And that pushes all the gold beads closer and closer together. And as they get super close, their energy fields start to interact, or couple, as the scientists call it. That interaction completely changes how they deal with light, which is why we see the color shift and get darker. Then you let go, the pressure is released, they spread back out, and poof, it's red again. It's basically a physical on-off switch for color.
Look, this color-changing thing is obviously amazing. But believe it or not, the way this material is made, well, that might be the even bigger breakthrough here. The real innovation isn't just what it does, it's how they built it. And the new method is all about simplicity and precision.
So, the old way of doing this was kind of messy. You'd have to try and create the metal nanoparticles inside the cellulose structure itself. It was a complicated chemical process, it could damage the cellulose, and you had almost no control over the final product. But this new method, it completely flips the script. The researchers take these perfectly formed, pre-made nanoparticles and just let them soak into the cellulose. And they self-assemble all on their own. It all happens in water, at room temperature. It's so gentle, so precise. Honestly, it's just elegant.
And this new process brings some huge advantages to the table. Because it's so controlled, the final material gives you a much cleaner, stronger signal, which is perfect for making sensors. The whole process is biocompatible, which throws the door wide open for all sorts of medical uses. And maybe the best part? You're not just stuck with gold. You can easily customize it. Just swap in different nanoparticles to get completely new properties. The possibilities start to really open up.
All right, so let's recap. We've got a material that's smart, it's sensitive, and it's surprisingly simple to make. So the big question is, what can we actually do with it? Well, this is where the potential really becomes a game changer.
So, where could this all lead? The research is already pointing to at least 3 incredible applications. We're talking about things like smart biosensors and antibacterial bandages, but then it gets even more futuristic, with ideas like controllable microheaters.
Okay, let's go back to that smart bandage idea. So in tests, they found that when a specific protein, in this case albumin, which can be a marker for what's happening in a wound, when that's present, it actually coats the gold nanoparticles. This little protein coating acts like a tiny cushion, and it changes how much the color shifts when you press on it. So think about it. You could just press on the bandage, look at the color, and get a signal that certain proteins are there. That could mean an infection, or it could tell you how the wound is healing, all without a single piece of electronics. It's amazing!
But it doesn't just stop at sensing, which is what's so cool. Remember how we said you could swap out the particles? Well, if you swap the gold for silver nanoparticles, which are famous for being antimicrobial, the film becomes an active bandage. I mean, lab tests show it can actually stop the growth of nasty bacteria like Staph aureus. So now you've got a bandage that isn't just monitoring a wound, it's actively helping it heal.
And this ability to control how close the nanoparticles are to each other, it leads to some other pretty surprising applications. It turns out that if you squeeze the film to pack the particles together and then you shine near-infrared light on it, those closely packed particles generate a ton of heat. We're talking a temperature increase 4 times greater than when it's just relaxed. This could open the door to creating these tiny biocompatible heaters that you could activate on demand, maybe for targeted therapies deep inside the body. Just incredible.
Okay, this is all incredibly exciting stuff. But, like with any big breakthrough, there's always a journey from the lab bench to the real world. So what happens next? What's the road ahead for this amazing touch-sensitive material? Well, the next crucial step is proving it can work outside of a perfect lab environment. Researchers now need to test its long-term durability, like can it handle being pressed over and over again? They've got to figure out if they can scale up manufacturing to make a lot of it efficiently. And probably the biggest test of all, they need to see how it performs with real messy biological stuff, like blood or serum from a wound, not just pure proteins in a dish.
But hey, these challenges, they're just the natural next steps for any real innovation. The foundation has been laid. We now have a way to create materials that respond to the world in a fundamentally new way. I mean, the ability to basically print nanoscale patterns just by pressing a film, that's a profound new tool in our toolbox. And that really just leaves us with one last question to think about. If you had a power like that, what would you build first?